welcome to this course curated by Factum Foundation for the Archive Online Academy. We are closing this cycle, which explored key challenges in heritage preservation, the reuse of industrial heritage and architecture in the Arctic, questions of provenance, restitution, and digital reconstruction, capacity building and digitization initiatives in South Asia, and much more. Today, we'll concentrate on new scientific methods for the digital analysis of cultural heritage. I'm very happy to present today's guests. We'll start with John Barrett and William Owen, talking about the portable Selene Photometric Stereo System and its role in research strategies. The Selene system has transformed how scholars, curators, conservators, and restorers engaged with the digitization of documents, artworks, natural history collections, and cultural heritage in general. But what new possibilities emerge when this technology becomes portable? John Barrett is senior photographer for the Bodleian Libraries and the technical lead of the Archaeox project, analysis and recording of cultural heritage in Oxford. His work involves the development of new methods of recording special collection material. William Owen is a consultant to museums, libraries, and archives, specializing in digital cultural heritage research and preservation. He has a long association with Factum Arte and Factum Foundation, and is currently working as advisor to Enrich, National Research Infrastructure for Cultural Heritage, a UK Research Council project to bring together all UK arts and humanities collection for academic and commercial researchers. Thank you to both. Thank you very much for participating today with us, and the floor is yours.
Thank you, Costanza. Can you hear me? And can you see my first slide?
Yes, both.
Great, fantastic. So good afternoon, everyone. Thanks, Costanza. Thanks for another opportunity to contribute to the Archive Online Academy. I think it's my third session, and I'm very happy to be able to share my work with you this afternoon. So in terms of what I'd like to cover, first of all, a summary of Archaeox and the Bodleian's collaboration with the Factum Foundation. We can talk about the Selene Photometric Stereo Scanner, and I'll give a very brief overview of how it works. I'm going to talk about the portable Selene and why it's necessary. I'll share some recordings from Oxford University Museum of Natural History, a series of prints by Dürer, looking at what the Selene recordings can tell us about paper, a set of drawings and plaquettes from the Ashmolean Museum, stylus incisions from an Anglo-Saxon manuscript, and how photometric stereo recordings have assisted in the research of parchment, and then a summary regarding the Selene and how it could be used as a tool for research. If you've not heard of the Bodleian before, it's a library which has served Oxford University for 424 years. It's the second largest library in the UK. It holds 13 million printed items, tens of thousands of manuscripts. And the buildings which comprise the Bodleian are among the most iconic in Oxford. Among these, the Radcliffe Camera that you can see here, and the 15th century Divinity School, which is the oldest surviving university building, specifically designed as a space for giving lectures. And it's a space where myself and the Factum Foundation have worked together to make 3D recordings. And that's what we've been doing over the last 4 years of Archaeox. Here we can see the Divinity School being recorded in 2024 using a combination of LiDAR and photogrammetry. And the recordings were made into physical facsimiles and digital facsimiles showing the incredible carvings. We've got a version of the entire ceiling recorded here. And that's work that's continued into this year. So in 2024, in February of this year, 70 more carvings were recorded by a team led by Imran Khan and his team from Factum, along with myself and Dylan Schermacher, who we can see here, recording one of the 450 carvings. And we worked long into the night, processing terabytes of data. So we've got Tiffany, Lulu, and Ferdy from the Factum Foundation processing that data. And you could be some of the first people to see a recording from those sessions. This depicts Samson sitting on top of a lion holding his jaws open. It's a really brilliant carving which wraps itself around one of the architectural ribs. So there's lots of work to be done to carry on with this processing and to make these facsimiles real. But this is the work that we've been doing with Archaeox, recording our cultural heritage in Oxford in 3D using technology conceived and made by the Factum Foundation. And that's only been possible through the generosity of the Helen Hamlin Trust, who have supported us since 2022. And back in 2022, it was photometric stereo rather than photogrammetry that we were focusing on. And this is Kohei Kano, who's the genius behind the photometric stereo scanner called the Selene. It's a 2.5D recording system. And the Bodleian were the first institution in the world to use the Selene. And it's been used thereafter to make literally thousands of recordings across the collections of Oxford University. Photometric stereo differs from photogrammetry in that it captures the surface of low relief or mostly flat originals. This 2.5D method of acquisition has the enormous benefit of being very quick to capture. It doesn't create a great deal of data, and it therefore permits capture at a much, much higher resolution than photogrammetry. The Bodleian's prototype has been incredibly effective and reliable. But in February of this year, Kohei visited the Bodleian again to install the latest version of the Selene, which has all of the benefits of 4 years of development. The studio Selene is now larger and even more robust than the prototype. It's a recording system which has been adopted by multiple institutions across the UK, Europe, and the United States. So just to talk about the principle for the acquisition of 2.5D data, it's really quite simple. So with the camera in a fixed position above the original, it's photographed 4 times, lit from different directions: top, right, bottom, and left. And the shadows and highlights from these images are analyzed in software, which is made by the Factum Foundation as well, of course, in order to determine the topography of the original. And from these source images, we can make useful maps which store the direction at each pixel using a combination of red, green, and blue to define the angle. This is what we call the normal map. And collectively, these angles or vectors map the surface of the original. And we can use those vectors to work out the topography and then encode height into another texture map, which we call the depth map. And it's essentially a grayscale image, a very efficient way of storing height data. By loading the depth map into GIS software, we can introduce a virtual light source, which we can position at any angle or height in order to create a render or a number of renders. Tools which enable relighting of recordings in a web browser have been developed jointly by Kohei Kano and my colleague at the Bodleian, Richard Allen. So this tool uses a normal map for the same purpose, relighting the surface. As the 4 source captures are simply 2D color images, they can be combined to create an evenly lit color image of the original 2. This we call the albedo map. And this is a big advantage. Previously, using the Lucía scanner, for instance, it would have been necessary to capture the 3D data and the color data separately and align the 2. But now we can acquire both the color and the 3D simultaneously, and they align perfectly. This slide shows a mesh model for encoding 3D data, and the same recording but made with photometric stereo is a far more efficient way of acquiring height data, perhaps 20 times more efficient at an equivalent resolution than photogrammetry. The Studio Selene can accommodate large originals, like this Elizabethan portrait. By entering the dimensions of the original, the Selene controller software calculates the number of image tiles required, and the hardware records the target area accordingly. Recording large artworks and maps without compromising on resolution is therefore very simple. However, the Selene is large and heavy, and it's not easy to move. However, in 2023, we took our prototype Selene to the Ashmolean Museum, which is down the road, to record a series of high Renaissance drawings like this Raphael study. It's a study for the Borghese entombment. It was drawn in 1506 and was a preparatory drawing for this work, Raphael's oil painting, signed and dated the year after. So the Selene recording has been very effective in revealing each stage of the drawing's construction. This has assisted in research. So from the render, we've been able to mark up geometrical constructions in lead and compass, blind stylus for the outlines, grey chalk drawn over the blind stylus, pen and ink for the anatomy, pricking for the outlines, and red chalk used for the body of Christ. So by using a combination of the color data and the 3D data, which the Selene's captured, we've been able to isolate each process and better understand the artist's approach. But when we moved the prototype Selene back to the studio, back to the Bodleian, we needed to adjust and upgrade the hardware. So it's not really portable. It's very heavy and difficult to move, and not especially robust. So in 2023, when we made the Ashmolean Museum recordings, the Selene certainly wasn't portable. In 2024, a prototype portable version of the Selene was developed and trialed here in Oxford as well. So the system uses the same camera and lighting, but it can be supported either from a small copy stand or mounted vertically on a tripod. So crucially, this allows for the capture of originals in situ. This large Elizabethan portrait was captured in a reserve, removing the need for the painting to be transported to the imaging studio. One of the most important elements of the Selene is that it uses custom flash units. As well as giving a very consistent output, it also means that the recordings could be made without needing to control the ambient light. So this makes recording in a gallery space or reserve very easy. Provided the original is captured from the correct distance, the recording can be captured and processed using a similar workflow. And given that the custom flash units rather than LEDs have been used, we didn't need to adjust the ambient lighting at all. So with this new portable design, I contacted other Oxford institutions and asked if I could spend a few days recording their collections. This is my setup, which I used in the Oxford University Museum of Natural History. And as you can see, all that's necessary is a copy stand, a table, and a computer. I've treated myself to a desktop here and a couple of monitors, but a gaming laptop would have been sufficient. And it took around 20 minutes to set up. And I spent the next 4 days making recordings like this one. This was my first recording of an object from the natural world. The Selene did a spectacular job of recording tiny details like the scales on the wings of this butterfly. And the butterfly has been captured at around 4 million pixels per square inch. And most excitingly of all, it's been possible to navigate the recording in the way that you see it now in just a couple of minutes from the capture. So that means that we can work alongside curators, researchers, students, conservators, and get an instant result. This is a complete game changer. So this is one of the Selene's most important USPs. As well as the museum's life specimens, I also recorded some of their earth collections too. This fossil was captured as a series of image tiles, far more crudely than you would with the studio Selene. Of course, we can't program it in the movements, but providing we have enough overlap between the images, it still makes it possible to join the image tiles reasonably well later in the studio. So this was probably about 12 image tiles. This fossilized collection of leaves appear to have a flat, uniform surface. But if we look at the render, it allows us to see the topography as it truly is, something very difficult or impossible to capture with a standard photograph. While I was making the recordings, one of the museum's curators asked if I would provide an overview of photometric stereo recording for her students. They were then invited to choose specimens from the museum's collections, which could be recorded. So this beautiful fossilized crinoid is one of the students' choices. In the render, we can see the relief, both in the shadow and through a spectrum of color. And over just 3 days, around 100 similar recordings were made and processed at the museum. The recordings could be analyzed within just a couple of minutes, and we can even take measurements from the fossils. This helps with identification. In this example, we see a small African bird's wing, and the Selene data has been used to produce this beautiful atlas render. And finally, from this series, a sample of snake skin, which shows each scale in amazing detail. These recordings made with the portable Selene show how effective photometric stereo can be for the research of natural history specimens. And they also demonstrate for many kinds of specimens how this can be done very quickly and without needing to remove them from their cases. So from specimens from the natural world to prints from our library collections, this is a recording of one of the 12 woodcut prints from Albrecht Dürer's Great Passion. Dürer engraved the series of woodcuts in Nuremberg between 1497 and 1510. This imagery is thought to be inspired by Raphael's Christ falling on the way to Calvary. This is an original edition from the Ashmolean Museum, and what we can see is some of the text from the reverse. But there are at least 4 Oxford institutions which hold prints from the Great Passion in their collections. The following recordings have been made from the volumes held by Wadham College, the Ashmolean Museum, and the Bodleian Library. This is one of the Bodleian's prints from a complete volume bequeathed to the library by Francis Dowse. But we have other prints from the same woodcut for which we don't have any provenance at all. Altogether, we have 4 prints depicting Christ being arrested. And we can see from the renders that the paper composition is entirely different from each of these 4 prints. So as well as looking at the fiber content of the paper, we can also examine the depth of the engraved markings. We can measure the frequency of the laid lines and the chain lines in the paper structure. And we can look for damage and alterations. This is the most comprehensive comparative material study of the prints made using the same woodblock which I've worked on. And the recordings have been used to further the research of Dr. Christina Niagu's research. Christina is a Dürer expert and former special collections librarian at Oxford University's Christ Church Library. So let's have a look at the albedos of the 4 prints side by side, and then take a look at the renders. We can see they look very, very different from each other. It's surprising to find that the paper which is discolored the most is likely to have been of a higher quality than the others, which appear better preserved. In fact, the render tells us a great deal more about the paper and the quality of the paper than the color image. In many cases, it may help us to date the prints. Sometimes careful examination of the high resolution albedo image is all that we need to provide important clues. We can see on the detail of the bottom of some of these prints, broken lines in this case, and even more prominently here at the bottom. If we magnify the same region even more, we can see that this is evidence of a repair in the print block. A tiny square of wood has been skillfully added to the region which had become cracked. You can see the crack coming from the top of the insert there. It's perhaps too much of a coincidence that this tear was made in the same region as this repair. So we can roughly gauge the date of the print from the presence of the repair and the length of the crack above it. But we can also use other forms of imaging to help us date prints more precisely. This is transmitted light imaging, which could be effective in revealing paper structure, showing chain lines, laid lines, and watermarks. If we rotate and mark up the transmitted light image, we can confirm when and where the paper was made. But provided that we record the side of the paper which would have been in contact with the paper mold, a photometric stereo render can reveal the same details. This watermark represents the Ravensburg coat of arms, and so it's likely that this was made in the second oldest paper mill in Germany, which was founded in 1393. This particular paper was made far later than that. The watermark dates to the 1470s. And we can see the same watermark in this print from Wadham College, and a very clear imprint in the photometric stereo render. So these two examples are likely to have been printed shortly after Dürer had completed his designs. The catalogue record for the Bodleian's print suggests a date of 1511. And the Ashmolean Museum have also got prints from the same series within their collections. In this example, showing very clear set through from the letterpress on the verso. A great deal of pressure must have been used. The Ashmolean prints may have been more difficult to research. Many examples have been laid down, pasted to a support page, making them difficult or impossible to record with transmitted light. But given that the Selene records the surface rather than through the surface, we can for the first time see the watermark with clarity. Renders from the Selene reveal other kinds of features too. In this case, reworking. The diagonal lines here are incisions made with a pen. Evidence that the nib of the pen is pressed into the paper to reinforce some of the lines which were not properly printed. Here's another example of a laid down print. The render showing the embossed letter forms from the text on the reverse. This print is from Dürer's Small Passion, presumably a more affordable, compact edition. And it's a rare, possibly unique version, a composite of two of the same prints with a removed section of the uppermost print around Christ's feet. This is Dürer's frontispiece from the Great Passion, and it's produced one of my favorite renders. So this is extraordinary. It shows the paper may have been damp when the print was made. I think an enormous amount of pressure would have been applied into the paper from the woodblock. It's even been suggested that this was intentional, that the print was intended to have a three-dimensional surface. So thanks to the portable Selene, myself and my colleague Dylan were able to capture dozens of Dürer prints in just a few hours and without the need for them to leave the Ashmolean's print room. The recordings were so successful that we were invited back by their curators to record a series of drawings and lead plaquettes using the portable Selene. Once again, it took only a few minutes to set up, and we managed to make multi-tile recordings from 5 lead plaquettes front and back, and an entire collection of pen and ink designs drawn by the Flemish painter Martin de Vos in 1577. Just as with the Raphael and Giulio Romano drawings, which we recorded in 2023, the Selene recordings reveal hundreds of stylus incisions, which were used to facilitate copying. As we zoom in, we can see these traced lines very clearly. The drawings illustrate the liberation of Antwerp, where Spanish soldiers mutinied in 1576 and sacked the city. The year after, a peace was negotiated following battles between Catholic and Protestant forces. The lead plaquettes, bearing the same design, are perfect candidates for the recording with the Selene, with variation in height of just a few millimeters and around 20 centimeters in diameter. Whether the plaquettes were simply inspired by Martin de Vos's drawings or directly copied from them has been a matter of debate. The question of how perfectly the two align might be possible to answer using these recordings made with the portable Selene, especially given that the high-resolution render contains far more information than a standard photograph. One of the most important advantages with photometric stereo recording is that render making and analysis can be done after the recording is made. Rather than making a series of rate light images from the original, the Selene recording can be digitally relit, viewed from any angle or height, and measured after the fact and back in the studio. By overlaying all of the recordings, we can transition from the albedo of the drawing to the render of its surface, and then we can blend into a composite render of the plaquette. No stretching or skewing was used during the alignment, simply repositioning and rotation. And so the recording confirms that an almost perfect registration between the incised markings in the paper and the drawing are present, and indeed to the embossed details of the lead plaquette. So finally, let's turn our attention to parchment. In 2023, I invited researchers to join me for my archive presentation to discuss how Selene recording has been able to reveal texts in early medieval manuscripts made from stylus incisions. Of course, the practice of writing with a sharp tool dates back far further. In the Roman and Greek traditions, text would have been incised into clay, into wood and wax. But we see this practice continuing for centuries and across cultures. This late antique Acts of the Apostles was written in Sardinia between AD 576 and 625. The text is both in Latin and Greek, and it's one of the Bodleian's earliest bound manuscripts. As with most early codex manuscripts, the parchment is extremely thick and cockled. The surface variation is in the order of 15 millimeters and on the limit of what can be recorded with enough sharpness. This small sample, recorded at over 2000 ppi, appears as a mountainous landscape when viewed in GIS software. Because of this relatively extreme variation and the low altitude of the digital light source across its surface, the shadows and highlights are especially hard. And this makes it difficult to mark up the surface details of just a few microns in depth. However, the Selene processing software can overcome this problem by producing texture maps which filter for textural frequency. By filtering out the high amplitude and low frequency variation, we now have a render which appears to have ironed the page flat. The high frequency incisions are now far more visible and easy to mark up. And this is the method which I use. Rather than working from a single render, I may use 4 or 5 lit from different heights and directions to make my markup. My image stack also contains an albedo, which can often show elements which don't appear in the renders, or vice versa. A new transparent layer is created, and the markup added using a pen tool with a diameter equal to the width of the incised lines. It's slow and careful work, and it's important not to mark up features in the substrate rather than the intentional markings. And this is the final result, a pricked cross and inscription, documented here for the first time. If you look at the size in relation to the entire page, it's easy to see why it's been hidden for centuries. But sometimes it's not the intentional markings which researchers want to study, but the substrate itself, both the structure of the parchment in this case and the way in which it has been prepared. This small Byzantine manuscript dates to 1225, and if we take a look at the surface of the parchment without the distraction of the text written on top of it, we can see the telltale markings made in the production of this piece of sheepskin. Parallel diagonal markings made from the parchment maker's tools. And we can see one of these tools in use here. The parchment maker you see is Giorgio Venice, a prominent expert in medieval parchment making, who has written extensively about the methods used for the production of late antique and early medieval manuscripts. His diagrams show how a single calf skin would have been cut to form a single bifolia folded through the center. Given that a medieval manuscript may be formed of 300 to 400 folios, a single manuscript might require around 200 animals. These may need to have been sourced from multiple farms. The markings on the surface of these skins are referred to as striation marks. They were created using a large lunar knife, shown in the red in this diagram, and a finer edged tool shown in blue. And it's been a great privilege to work with Giorgio on a 5-year research project called Insula. It was a project conceived by Professor Joe Story, selected by the European Research Council and funded by UKRI. The aim of the project is to examine early medieval manuscripts across multiple institutions and to transform our understanding of the influence of Anglo-Saxon and Irish missionaries in early medieval Europe. And to do that, the project is making use of cutting-edge recording techniques, not just 3D imaging, but also things like biocodicology. We can see some of the outputs from the project in the next few slides, renders which show parchment features in a way that's entirely new. Here we see what Giorgio describes as a belly button repair, where the hole in the parchment has been closed by pulling and tying the surrounding skin together. And this flay cut shows how a thin region of parchment, perhaps part of the skin next to a bone, has formed a hole. This has been tidily cut on the lower edge and left in its raw state at the top, the animal's hairs appearing a bit like an eyelash. We've seen the same technique being used in multiple early medieval manuscripts. We can see other flay cuts from the pages of this very important manuscript, the earliest text of the Rule of St. Benedict, dated to around 690. Each recording has been captured at 4 million pixels per square inch and are capable of showing the striation marks and hair follicles, which are valuable in Giorgio's research. The recordings show skillfully made repair work, which has lasted 1,300 years. And these novel parchment preparation techniques and traditions were later adopted in the continent. And of course, we shouldn't limit ourselves to trying to answer research questions. Recording artwork simply based on its aesthetic quality can be done very simply with the Selene because it's so easy and quick to do so. And this is how, for the most part, I've used the Selene and the portable Selenes over the last 4 years to record small samples, to work quickly and record as many different elements as possible without creating too much unnecessary data. The Selene is an incredible tool for research imaging. It's providing new information which is of genuine benefit to the research community. And it continues to excite and amaze myself and my colleagues and the researchers who we work so closely with. Thank you very much.
Thank you,
Thank you, John. Shall I start sharing my screen now, Costanza?
Yeah, sure.
Hello, everybody. Thank you very much for inviting me to speak, Costanza, with Archive. I'm going to make essentially make some concluding remarks, I think, to John's talk, insofar as I want to talk about trade-offs and use cases. In other words, one particular and important aspect of a portable Selene, which is that in any field of research, there's a tension between the expectation of discovering valuable new knowledge and the rigor and cost involved in acquiring it. You're always wondering, is this avenue worth pursuing? And I think what we tend to see, for example, in all of the wonderful examples that John has shown, are the things that produced good work. I'm sure there are certain things which were not quite as exciting, perhaps as promised, but that's always a careful calculation that's been made that the portable Selene should make life much easier with, in terms of answering the question, when do you commit? This is the question it's going to help to answer. There are other important aspects of it as well, including that which involves working directly with researchers and to start to understand exactly what one should be looking for and how one should pursue a particular goal in research. The Studio Selene has a bar set quite high insofar as it's serving the use case. I want to make a detailed, complete, high-resolution study of the color and relief of an object for analysis and study and/or preservation or reproduction. And so it's often involved in some quite significant projects. There is an investment in bringing artworks to the studio in transportation, perhaps insurance, but also perhaps use of a specific workflow that involves conservation inspection before scanning or before anything is moved. And the scanning itself, the post-processing, and sometimes repeating the work to understand a different facet of the object. So it is a big commitment and investment that's asked when you're going to be using a Studio Selene. So what we're hoping is that the portable Selene really opens up the opportunities to start to look at different things and to decrease the risk of that initial investment. One example of a big project would be the Goff map at the Bodleian, where, sorry, one moment. A program at the Bodleian which produced some outstanding results, including new understanding about when and how the map was made, the existence of a precursor map, creation of a facsimile for public display. So again, a major investment requiring months of conservation, recording, post-processing and fabrication, and one that in this case paid off handsomely. But there is, of course, always the risk that research findings will be absent or uninteresting or use up more time and resources than the result justifies. With the portable Selene, one's answering the use case helped me decide whether to invest time and effort in a detailed, rigorous investigation. So in some ways, the object is working more like a loupe or a magnifying glass or a microscope than it is as a recording device for start. And as a result, it has to be easy to carry around, it has to be robust, and it has to be simple to use. With a portable Selene, the technician and researcher can make a quick in situ analysis to answer the question, is it worth investing the time in this? The portable Selene itself is fundamentally the same machine as the Studio Selene, with some important differences. One is that it fits inside a flight case and can be moved all around the world wherever you want to go, or even just down the road, where I can think of certain cases where that could make a significant difference. It's easy to operate and maintain. You can take it to a museum store, work in a gallery, or as John's explained, in a conservation studio. The typical scenario is to scan a single tile of the interesting portion or portions of a large object, but you'll see examples that I'm going to give of using the portable Selene to scan the entire object where it's small enough. And again, the sort of mindset around Selene is very much around looking at quite large objects, but in this case, we can start to change the mindset and think about quite small and potentially or apparently insignificant things which can tell us a great deal. I'm going to give some real-world examples, which first of which arose when we were talking to the National Archive in Kew in London, having conversations about different ways of using the Selene. And in fact, John's carried out a number of trial scans on different object types. This was done at Factum Foundation Studio in London, so it was before the portable Selene existed, but these are all very good examples of something that you would actually have used the portable for within the National Archive's own offices. The first example is a wax seal from the Civil War Parliament after the execution of Charles I in the 16th century, 17th century. You can see in the image on the right, in fact, the Speaker of the House of Commons in his chair at the centre with all the MPs around him wearing their Puritan hats. So this seal is a record of gentleman's fashion as well as political upheaval. The reason this cropped up is that we'd noticed that the archive was using direct casting to make plaster casts of the fragile seals that it has. There's an image of one on the left. Our goal was to demonstrate that a photometric stereo scan could provide the same or better accuracy to create a mold using a non-contact technique instead of a contact technique like plaster casting. These are the three states of the recording of the seal. You can see the albedo color on the left, the relief in the center, and composite data on the right. And here's a blown up example of the composite data, which reveals in much greater detail the speaker and the MPs, but also the fingerprints of perhaps a past conservator or curator at the National Archive, or even perhaps those of a parliamentary clerk in the 17th century. So again, immediately one could start to examine phenomena like this. And so while John was making the recording, the National Archive conservators were there, and they could see the track through the fingerprints in section. So there's one example of thinking about making a facsimile in the future. Here's another example, which is about thinking about conservation and whether it's necessary or not. Conservation also requires some quite difficult decisions about whether to move forward or not. And in this case, we have a 19th century manuscript in a then fashionable neo-Gothic style, which was inspected to explore certain conservation concerns. You can see in the image on the right at the top, there is red ink peeling away. It's very evident that it needs conservation, but also the conservators were worried that pigment in the black ink had separated from the medium in which it was suspended and required fixing. Again, from the section, it was obvious immediately that that ink was blown and would need conserving. We had another case where it was shown that it wasn't and did not need conserving. So one could make both positive and negative decisions effectively and save money by doing so. This is the hairy ledger, as they called it, which is a vellum binding of the inventory of Edward II's Master of the Robes, his list of the valuable silks and furs, which would have constituted a very significant part of the king's wealth. It's early 14th century, and the concern here was again around conservation and evidence of insect damage on the very hairy carved vellum. And we were interested in looking at two things first. One, could the Selene actually capture the hair, which is quite a difficult thing to capture from an overhead technique? And the other, was there actually damage present? And here we have, again, two snapshots in the three different states of different portions of the vellum binding. And it became obvious from the depth map that there was indeed insect damage there and that conservation would be necessary. The next images are of two different editions of the Declaration of Independence made on July the 4th in 1776 by the printer John Dunlap. He made both of these, the one on the left in Philadelphia, the one on the right in Baltimore. And the question was, how were they both published on the same day when they're 100 miles apart? And it became what became clear from some early analysis and then the Selene analysis that in fact they were made from the same galley of type. And so John Dunlap presumably got on his horse with the galley of type and rode off from Philadelphia to Baltimore and then to a print shop where what became obvious from the Selene was that, hold on one second, here's one example and here's the other, and you can see quite clearly that they're using different paper, but nonetheless the typography is absolutely aligned except where there are creases or stretching in the paper, and that's something that's a conclusion that's not confirmed but warrants further research. Another of the organizations making extensive use of the Studio Selene is Princeton University Library, the Firestone Library in New Jersey, and continuing our colonial revolutionary theme, the object that you can sort of see here is, just give me one second, is the revenue stamp for the first official tax on American colonists imposed by the British Parliament in 1765. So 20 years or so, or 10 years or so before the Boston Tea Party, but nonetheless, of course, of angst and rebellion amongst colonialists in New England. It's a good example of an object which is very poorly represented by photography. It's quite a small object, just 2 or 3 inches square. But in relief, its content becomes much clearer. And again, in a composite, clearer still. This is actually an example that's currently on display at an exhibition at the library on Nursery of Rebellion, which also happens to include a copy of John Dunlap's Declaration of Independence, which exists at Philadelphia Library as opposed to the National Archive in England. The other use, or the other obvious advantage that the portable Selene has, is the ability to capture objects that are small enough to be shot in a single tile. So there is very little post-processing time necessary, and it's the kind of thing that a researcher, a technician, and a conservator can look at simultaneously and talk about how exactly they want to show it. This is quite a tricky object. It's chalcedony, a form of agate stone. It's a Bronze Age stamp seal, so it's an intaglio steel, shaped as what precisely is very, very difficult to see from this photograph of the color spectrum. In relief, still not extremely obvious, but you can see it is in fact a lion's head. So it's a very good example of the way in which Selene can reveal the actual state of something and what its intention is. Portability is the key to acquiring certain classes of object, and one of the things that we discussed with Raul Munez at Princeton was how they would be able to use the portable Selene to bring objects from the museum, which is literally 300 yards away, but which they can never bring objects to the library from to be scanned by the Selene. That opens up the portable will open up the entire museum to them as a source of data. The other obvious example were wax seals on treaties between Native Americans and English settlers, which exist all over the United States, and which they've been working with a researcher to start to record, and they would now be able to record them all using the Selene and bring them together as a single digital record. The sorts of items that I've just been showing you are ones that are, in most cases, obviously have obvious three-dimensional properties, and which are very commonly recorded using the Selene. And the last bit of this talk, I just want to talk about a general question of mindset and the appreciation that the art world and art connoisseurs have of flatness and of texture and relief, and the lack of knowledge of the knowledge that can exist within relief. It's something that perhaps has its roots in 200 years of photographic reproduction of artworks, which makes it rather difficult to appreciate the textural qualities of painting and to forget them. It's an ingrained idea that paintings, drawings, and other two-dimensional artworks are perfectly flat because that's how we see them in books, and that's how we see them in magazines and on the internet. This photograph is actually the first known photograph ever taken. It's of an artwork. It's by Nicephore Niepce. It's of a 17th century Flemish engraving of a man leading a horse. Photographing art began at the very beginning of photography. The next is by another of the inventors and founders of photography. This is the first known daguerreotype by Louis Daguerre. And again, it's of a group of artworks this time, some of which, like the putties there, are evidently three-dimensional and with relief. There's also, though, a picture in a frame at the back, which is demonstrably flat, or is it? The third image, again, from the very beginning of photography, are illustrations of two bas-reliefs that were included in William Sterling's book, Annals of the Artists of Spain, which was the first ever history of art that was illustrated by photography. It was also illustrated by engraving, and was a very good demonstration of the incredible sophistication that engraving had got to in making very exact reproductions of works of art, and the lack of technical sophistication of photography at the time. It was very much an experiment. And as Sterling said, there's a quote from him there, the bas-reliefs are probably the first which have ever been made by a mechanical process, and indeed they were, along with 60 or so other images. There's another that Henneman made with the same batch of works that wasn't actually included within the book. This is Goya's Boys Playing at Soldiers, which was owned at the time by Sterling. And this was the world's first ever, as far as we know, recorded photograph of an oil painting. And as you can see, there is no relief, no texture. There's obviously also no color. There is only shade. What texture can be seen is actually of the paper on which the salt print was recorded, rather than anything that was present in the artwork itself. But just to compare that with a modern photograph of the same painting, which is today in Glasgow Museum, again, the color is there, but there is no texture whatsoever. That particular picture comes from Art UK, where, as a product of the internet, everything is looking very, very flat indeed. All of the photographs, and this is a directory of every publicly displayed oil painting within the United Kingdom. The world of art is entirely flat. And here's another section from the same website. And as you can see, the second from the left, Van Gogh's Sunflowers. Here we have it, just as we would expect to see it in a photograph. And then if we just add on the right, here is the Selene's view of the same image. that's just there to start to think about perhaps how the portable Selene will be able to make these things clearer more quickly and without massive investment up front, and enable it to get further into art institutions around the world. Um, and uh, on that note, I shall finish. Thank you very much.
Thank you very much, William and John, again. I see that there are already a couple of questions. This is maybe more for John. How large is the data file for these recordings with Selene? Do you need a specific software to open the final 3D object? And can they be shared easily with outside researchers?
It doesn't create too much data, like comparatively, certainly comparatively with photogrammetry. So a single tile recording, the raw files that you would create for that recording would be 240 megabytes. And then the texture maps and a single render would be another 460. So altogether, less than a gigabyte. And bear in mind that in the rest of the Bodleian's photographic studio, our 2D images are about 300 megabytes. So it's not a great deal more than just a normal 2D image. In terms of the software, it depends what you want to do. So the software which you process those source images into texture maps in, which is designed by the Fetton Foundation, will give you a grayscale render. So you can select where that is going to be virtually lit from, the azimuth and altitude of the sort of virtual light source, if you like. So you don't need additional software. But if you want to view the recordings in the way that I sometimes showed in my slides from different angles, so if you're viewing them from different angles rather than just orthographically, then you would need GIS software to take a look at them in that way. That's quite expensive. It's a few £100 at least. But Factum are working on a solution which would be more proprietary and probably a better fit for Selene recordings. So that's something for the future. And in terms of sharing the recordings, well, renders can be just two-dimensional images lit from different angles and heights. They can combine some of the albedo to create a composite image. William showed a few of those in his slides. And those can be surfaced very easily on a digital asset management system or a website where you would share your images freely. So you don't need anything special. If you wanted to allow interactivity, so the ability to relight them virtually, so the user to be able to relight them, then the tool which I alluded to, which is co-made by Jorge and Richard Allen at the Bodleian, will work on any IIIF compliant normal map and albedo. So that is available for any institution to use, provided that their images are IIIF compliant.
Thank you. If I may add, yes, you showed, I think, a couple of examples of the IIIF viewer, and probably my colleague in next class in a few minutes will show some example of an example of multi-layered viewer, so to inspect the albedo, the color, and the shaded render, so the texture combined or separate. Can you record 3D object like statues with Selene?
You could record the surface of an area of the statue, but 2.5D recording is really for low relief originals. And what we mean by that is mostly flat originals. So originals which have a surface variation in height of about less than 15 millimeters, let's say. Because we need to preserve that depth of field. We need sharp images in order to facilitate that photometric stereo calculation, just as we do with standard photography. You know, when you run out of depth of field, then the image looks soft and it's not usable. So no, it's a recording system which is incredibly quick, and doesn't create too much data, but it's really meant for low relief surfaces. If you wanted to record a statue, then you would need to use photogrammetry. And I opened with some slides where we were using photogrammetry and LiDAR to record things which are truly volumetric.
Thank you. Then there is another question about if there is a chance to take a training course or workshop. And I would say that, well, staying tuned with archive activities and Factum Foundation activities and Archeox too is the best way to know. So let's stay in touch. And well, for hopefully next fall, in the context of Archive Online Academy, we'll also propose a in-presence training course of several technologies, probably also Selene. This is still to be confirmed. Well, doing workshops is part of the activities that we do together with Fondazione Giorgio Cini for the archive project. So let's stay in touch, let's say. This second part of the class will be held, as said, by Santiago del Bosque Arias and Lucía Pereira-Pardo. They will present pilots and scientific investigation on how to combine photometric stereo data that now we got familiar with, and combining it with hyperspectral imaging by identifying pigments through their unique spectral fingerprints, and combine the 3D recording of the surface of objects. This integration opens new possibilities for studying cultural heritage without, of course, ever touching the objects. I'm very glad to welcome Santiago del Bosque, art historian specialized in technical art history at UNAM in Mexico City. He's part of the Selene team at Factum Foundation, where his multidisciplinary approach integrates preservation, audience engagement, and technical development. And with us today here at Factum, it's an exception. It's a mix of online, on-site thing. We have Lucía, heritage science specialist focused on technical art history and postdoctoral researcher. She's principal participant in the archaeology specialization at INCIPIT, one of the institutes of Spanish National Research Council, the CSIC. Thank you again for being with us, and the floor is yours.
Thank you, Ghosts. Let me share our screen. There we go. Thank you, Ghost. Thank you, everybody. It's a pleasure to be here with you and with Lucía, of course. Thank you.
Thank you for inviting me.
Yeah, it's incredible to have you here and being possible to make this presentation together. So this presentation is about combining photometric stereo data with hyperspectral imaging, or RIS, which is reflectance imaging spectroscopy. Is the same. We use both names. Pilot scientific investigation. First of all, I would like to start describing a little bit about the organic workflow that we have here in Factum Arte and Factum Foundation. Because the first step is the connection that we have with the object. The second is the scanning, the digitization, and the conservation assessment of this. The third part is the data processing for visualization, all of this information that we achieve. The first step is the data analysis of this, and the fifth is the possible rematerialization of the object. In this case, we are going to focus on the second, third, and the fourth step. Okay, so it's a pleasure, Lucía, again, please explain us a little bit about the incipit, the SIC, and the techniques that you work with.
Okay, thank you, Santi, and thank you, Coach, for the introduction. So for those of you who might not be familiar with the Spanish research system, I'm going to tell you a little bit about our organization. So I'm going to explain what the SIC is, what our particular institute, incipit, works on, and also tell you the good news about the new laboratory we are trying to put together, focused on the analysis of cultural heritage materials. So let's move on. So the SIC is the acronym of the National Research Council of Spain, and it's basically Spain's largest research institute, reporting to the Ministry of Science. It kind of spreads across the geography of Spain, as you can see in the map. The SIC is made of about 120 research centers, and each center will have a discipline or a particular topic. So we have an Institute for Nanomaterials in Zaragoza, for instance. We have a Center for Nuclear Investigations in Seville, and our particular institute focuses on cultural heritage. We are about 15,000 members of staff across all the institutes in Spain, and our functions, as you would expect, is to generate new knowledge, to transfer that knowledge from academia to society. We also provide independent advice to public bodies or also private entities as well. We train research personnel. We don't teach in the university, but we do receive PhD students or young researchers to train with us. And we are very committed to scientific dissemination of the research breakthroughs, scientific culture, and we also participate in international networks of research infrastructure and scientific networks in general. Specifically, the institute where I'm based is the Institute of Heritage Sciences, incipit. And we are a bit peculiar in the sense that we are multidisciplinary. So as you can see in the picture, we are around a big kind of medium-sized institute, about 100 people, and of very diverse backgrounds. So we have many colleagues who come from archaeology, from the archaeological science as well, anthropologists. We have a group who work on anthropology, and they collaborate very closely. And more recently, we are incorporating chemists, biologists, and physicists as well. As I'm going to tell you next, we are creating a laboratory infrastructure. This is our lab. When it was brand new back then, when we took this picture in 2023, it looked very empty. And now it's full of things. Luckily, we have managed to secure funding to buy, to acquire analytical instrumentation. And I kind of prepared a little visual summary under the picture of our lab of the techniques that we currently have and that we are in the process of buying. So I like to organize the equipment into kind of branches, as you can see on the right. So my background is mostly non-invasive techniques. So most of them are portable. We can take the lab to the museum instead of moving the objects or taking samples. And we have microscopes, XRF, so X-ray fluorescence spectroscopy. We also use imaging techniques, and that's the main focus of our talk today. We combine multi-band imaging in the ultraviolet, visible, and infrared, near-infrared range with hyperspectral imaging, which provides also chemical information on the composition of the materials through reflectance spectroscopy, Fourier transform infrared spectroscopy as well in the portable version. And we are in the process of buying a micro-Raman spectrometer and also an XRF scanner. So not just to do point analysis of the elemental composition of materials, but also to do small maps to kind of map the distribution of elements, particularly metals, in both pigments and metallic objects, different applications. We also have some benchtop instruments. You can have a look through the list. I'm not going to focus on that today. So let's continue and talk about the kind of applications of our focus of analysis. So why analyze heritage materials? I guess you could organize the different disciplines that can benefit of this analysis by methodology and by the kind of questions and goals they are after. So the most common, perhaps the one that you'll be more familiar with, is conservation science. And in this case, we combine material analysis with aging tests, so accelerated aging tests, to understand how different materials perform in the long run, in case you want to incorporate them to your toolbox as a conservator, the development of new methods and products for conservation, and also from a preventive conservation angle, environmental studies. And why? What's the goal? So to determine the conservation condition of an object, to understand better the causes and mechanisms of deterioration, and for instance, also to make informed decisions about the best treatment for a particular case, for a particular object. In parallel, I'm showing you other kinds of applications of the analysis of heritage materials. And they might not look similar, but I think they are. I think they share many things, which are archaeological science and technical art history. So archaeological science would combine the analysis of the materials with, of course, the information obtained through the archaeological record. And technical art history instead would use written sources and also recreation in the laboratory of the old recipes for imagine painting or a particular technique of polychromy, for instance. But the goals are very similar. We are both very interested in dating objects, determining their geographical origin, trade networks, and how were they used, especially the production context, the manufacturing, how were objects made, authorship, what kind of groups or schools or workshops were working in this particular way, using these techniques and these particular materials, and also methodological development. That's also very important because it opens up possibilities to ask new questions.
Yeah, and I think this is a really good example of multidisciplinary work, I think.
Absolutely.
Because in too many cultural institutions and in too many research centers, you have some scientific and art historians and archaeometry people. So it's like the perfect example of multidisciplinary studies.
Yeah, they're working together. I think I concluded that we have many things in common because at the moment I work surrounded by archaeologists, and I can see that their methodologies, the way they work, is not so far from what I do. And we are starting to collaborate and to learn from each other and to discuss. And I think that's true multidisciplinary research, and it's very enriching. It's not always easy because you need to understand the language and be able to communicate. But it's
the perfect way to understand together, to have some kind of final results about something. It's at the end of the day, it's the kind of way we communicate each other.
It's much more comprehensive. Okay, so now we know where we are, what we do. We're based in Santiago de Compostela in the northwest of Spain. I don't know if I said that. So I want to just give you a very brief overview of the kind of research projects we are working on at the moment. I'm going to show you two. So the first is the Museum of the Invisible, and it's a bit of an exploratory project where we are addressing conservation problems that limit our capability to see texts or images on cultural heritage objects. And we are trying to pick those cases that are the most challenging, that are kind of beyond conservation capacity, and see if we could address that digitally. So using advanced imaging and processing methods that can help us recover the readability or the visibility of texts and images on different kinds of heritage. So those are basically the goals. I don't want to spend too much time on this. The second project we're working on at the moment deals with technical art history, which is a relatively new discipline that looks at cultural heritage as artifacts, as objects that contain information in their own materials, kind of a material archive of the biography of that object. Because often in art history, we are very formalistic. We look at style, we compare the iconography, but we don't interact with the object itself. We don't handle it with it's a bit like what William was saying before, that we are used to see pictures like, are really flat and just think of them as images isolated in space. And I think introducing this material aspect and reflecting on the materials from a historiographic point of view is very enriching and has a very promising future. So basically, technical art history kind of started in British and I would say American, North American context, also in the Netherlands, were kind of pioneering this discipline. But in Spain, it's still very new. We have a long tradition of science applied to conservation questions, but not so much to art history. So my goal with this project is to develop a research line on technical art history in Spain, to combine material analysis with more classical art historical research using archives, written sources, stylistic analysis. To do this, the main tool is a non-invasive laboratory. So that was the second goal, to build and consolidate a set of portable techniques that we can take to the museums and work there in a non-invasive way. And finally, we are working through a strategic selection of case studies to contribute to historical debates that are unresolved and try to provide different perspectives on this. Also I don't like to work on individual objects, but to look at connections. So to look at collection series and establish the relationship, connections and differences between them, because that's when things get really interesting, when you start looking at the big number of objects and you start noticing trends or changes or influences between media or guilds. And for instance, I'm very, very interested as well on transculturality. And I think the Iberian Peninsula is a great place to look at how materials and techniques and knowledge have traveled from across borders in terms of geography, but also religion. So I am very interested in looking at that kind of phenomena from the material point of view. Just a quick overview of the techniques we are going to be talking about today. Multiband imaging, I mentioned it before, is a qualitative technique. So we won't be able to extract spectra from these images, but they are very high resolution, and they can show us layers under the surface to reveal, for instance, preliminary drawings, pentimenti, so changes in the composition for the final version of the painting in this case. It also highlights restored areas. So as you can see, let me see if my mouse works. So here you can see like a darkened area that is retouching in this illuminated photo in this manuscript. We can also study luminescence phenomena, because organic materials tend to emit luminescence at a particular wavelength, with a particular color. And also we use it to recover faded ink. Iron gold ink under UV light, as you might know, becomes darker. The contrast with the parchment often helps to read texts that are completely lost. Combining this imaging technique with other methods like microscopy or the analysis of the elements, chemical elements, you can even date the intervention, the restoration intervention, and understand much better when things happen. So as again, the biography of the object, and understand like different stages in their story. The other technique we are using and we are talking about today is reflectance spectroscopy in general, which could be used as point analysis. So in this case, you have a fiber optics that brings light to your area of analysis, and it's bifurcated. So it collects the reflected light and goes to the detectors in the spectrometer. So you obtain this kind of graph. It's a reflectance spectrum, where you have wavelength in the visible and near infrared versus intensity, reflectance intensity. The interesting thing is that the different colors, the different pigments, will have particular features. So transition edge at a certain wavelength is characteristic of vermilion in this case, or this absorption band in the blue spectrum with a minimum at 600 is very typical of lapis lazuli. So you can quickly identify materials just by shining light on them. It's very quick, very easy. And in their imaging version is even more informative, because we were talking about what's called force, the previous technique, on a point of a few millimeters diameter, but you could apply a similar technique to a whole area if you use a hyperspectral camera. So basically you obtain a data cube, and each pixel of the cube of the image will have a spectrum. So very quickly you can get information of across the whole surface of a painting, polychrome sculpture, manuscript folio. We're going to mention also X-ray fluorescence, because it complements very well the previous techniques, in the sense that it allows you to analyze, for instance, metals like gilding in paintings or sculptures, inorganic pigments, inks, the mordants for instance, in a textile. So anything inorganic, you can determine the elements, while before we were looking mostly at compounds, molecules. So here we can see the gold, and we were looking at a retouching in a palimpsest. So we were looking at the different composition in the gold ink, and in fact we did find that the purity was very different, and we confirmed that this was a modification of the text, later addition, just to show you an example of the application. Okay, so now you know everything about Incipit, you know a lot about the techniques, you are aware of the projects and our goals. So let's talk about this collaboration between Factum and Incipit, and what we are trying to do, which is merging chemical information in our hyperspectral images with texture relief in the Selene captures. So back to you, Santi.
Thank you, Lucía. Yeah, I would like to talk a little bit about the beginning of this idea. Back in time, more than a year ago, we installed a Selene Photometric Stereo System in this incredible institution, Instituto Valencia Don Juan, which is open to researchers, and the collection of Islamic and Hispanic art is incredible. So if you are researchers in these items, you can have a look on this site. And okay, we were there scanning this piece, Miguel and I, and then I had this question: what is the relationship between the relief pigments, the binders, the mordants, of course, and the supports of an artistic object? Because they are related, of course, but which is the level of this relationship? Then, after some weeks, I realized that we will be a conference in Zaragoza with Lucía and in Kibit team, and I said, I have to talk with them about this, because I think we can merge the techniques together, and let's see what happened, because the relationship, picking together the ideas of John, William, Lucía, and my own ideas, we have to analyze the relationship that we have with the objects. They are not only images. Nowadays, art history, most of the time, is based on imaging something on the wall or in a classroom, and that is not real. We have to improve our relationship with materiality. And we have to improve the time and patience that we can spend with an object. Two things that right now it's really difficult. Even if we are researchers, art historians, conservators, curators, time and patience is something that we don't have when we are creating those connections with the object. And with this technique, with the Selene, and if we apply more techniques, we can improve the time and patience. We can improve the relationship that we have with the objects. So this is the first time that on your left-hand side, on the screen, I went to Archivo Histórico Nacional here in Madrid to talk with them because some months ago we have scanned this particular and incredible manuscript, which is really important for the history of Spain, Tumbo Menor de Castilla. This miniature is incredible. And on your right-hand side is the same week, I suppose, maybe, yeah. The 2 or 3 days after, so the next day, I don't remember, but the first time that we made some tests with the hyperspectral camera, analyzing conical textile at the Institute. So this is the first one, and
okay. So that day we were acquiring hyperspectral images of this miniature in the Tumbo Menor. We were trying to characterize the palette because we are very interested in understanding the manuscript production in the Kingdom of Castile in the 12th century. So this fitted really well as a comparison to other manuscripts we have been looking at. And here you can see the infrared, so the black and white image, the grayscale image you see in the center is the infrared band at, well, the 900 nanometers band in the infrared. And immediately you can kind of guess what kind of pigments you have there. If you look at the blue and the greens in the color image, you can see that they become quite dark in the infrared. So immediately, if you have in mind the possible suspects, the pigments that were used around that time, you would think of copper-based blues and copper-based greens. We complemented that analysis with other techniques, like XRF, and we confirmed the presence of copper in those areas. Here you can see the reflectance spectrum. Also, the red is very clear. So from the hyperspectral cube, we could extract an average spectrum of this area, and we saw that it was vermilion. So it has a very clear transition edge here around 600 nanometers, confirmed again with XRF analysis that gives you the chemical elements, so mercury and sulfur. So it's a relatively simple palette. We could characterize it quite quickly, but as you can see, this is a map of the distribution of those materials. So basically, using this algorithm that is called spectral angle mapper, you could map pixels that have a similar spectral response and therefore a similar chemical composition. But see how flat it is? We are missing completely the texture, any incision, any extra information that Selene could give us. So when Santi told me that they had actually scanned this particular book a few months before, that's when the idea came. Like, okay, let's see if we can merge what you do and what we do and see if that kind of enhances the information that we are obtaining. So let's see what happened. Is this the video?
Yeah.
Okay, so let's show you.
This is an example of the multi-layer viewer. As Lucía was explaining, this is really important because some of the questions that we have, and not only we, the conservator of the Archivo Histórico Nacional, they are worried about the conservation of the vellum and the conservation and the relationship between the pigments with the color, and of course to determine the origin of this. And
I don't know if you saw before, but you can see like brush strokes, like here around the sword, there is a red brush stroke kind of around it that we have completely missed. I only noticed it when I looked at the Selene scan. Here you can switch layers, as you can see. So you could compare any imaging technique that you have acquired. You can overlay it to the texture map obtained by Selene. What you have on the left is a false color image. So it helps you understand to see how materials behave. On the right, I think, is the spectral angle mapper from the hyperspectral camera. It also shows you the areas of paint loss in the background where the pigment is detached. Same in the halos. The golden halos have lost part of the of the gold. And see that image, that kind of loss on the left, that becomes much more evident when you overlay our color images or our false color images with Selene. You can see you can almost feel the depth of the loss and how thick the paint layer is. As Santi was saying, you can also see the texture of the parchment, the areas where it's more deteriorated, more fragile. So I do think it does provide much more information than the techniques separately. Right? Well, I don't know what the conservator said when you show them the scans, but I guess they would be pleased. They were pleased.
They were very, very happy, because as you see on your left-hand side, you have all the information. In this case, it is in Spanish, but with this icon, you can understand what are you looking at. And as we have been explaining, it's really important that it all depends on the questions that you're making to the object as a researcher. And the techniques that you are going to apply depends on that. And in this case, the questions were about, of course, the relief, the micro relief on the surface of something that most of the time people have this idea that it's completely flat, but it is not flat. It's a shallow relief surface. And of course, the other questions about the provenance or the origin of the pigments. And with mixing together, we can understand a little bit more better. And when we achieve more information, we can formulate better questions. So it's something that is all the time, as we do as human beings. It's like developing, and continuously it's changing and growing all the information that we have about this.
I also wanted to mention that this viewer is a great tool for research, because it allows you to spend more time and patience as you're there looking at details that with the actual object you would probably miss or won't have the time to explore in depth. But also I think it has a lot of potential for communicating results, because images are very powerful. It's much more friendly to present the conservators or the curators your results in this format than sending them just random spectra and like a paragraph describing the bands in the spectrum. I think this is great because you have this, it's IIIF, right? Based.
This is our own.
Is your own viewer, sorry, okay. But the what you showed before on the left, that you can display the different layers and have a description of what they mean, what they show, what can they be used for. I think it's very didactic.
Exactly.
So
it's not only for scholars or researchers or curators, for students.
For teaching,
teaching,
for training. I think it has a lot of potential in that sense.
Yeah, that is one of the most important things using this technology and using this kind of visualization technique. As you see on your screen, this is the first screenshot that I shared with some researchers, manuscript researchers, and they were amazed by this and all the time asking, how can you do it? And something important is the resolution, because in the case of Selene, the resolution is more than 1000 dpi, sorry. And on the other hand, hyperspectral nowadays, and this time, it's not possible to achieve that resolution. But mixing and merging the images, it's like the perfect match, because the information that you have about some pigment transform immediately in something more using the micro relief information.
So you get the best of both worlds, because you can project your chemical information on a very detailed map of the texture of the surface. So you benefit from the strengths of both techniques. Is really correct.
Going through the limits of the naked eye.
Exactly.
The next object, also, this object is it's a Coptic textile from around the circa 6th or 7th century, the Instituto Valencia Don Juan here in Madrid, and it's better if you explain this part on the left-hand side.
Okay.
Yes.
Let's do that.
Purple pigments and organic fabrics here is something that we have to analyze with too many detail. This is the first results.
Exactly. Like, keep in mind that these scans happened like 2 weeks ago.
Yeah, one and a half week.
1.5 weeks ago. So we've been processing it very quickly and looking at the results and trying to get an interpretation to show you. So this is the first time we show this. So this kind of latentic Christian Egyptian textile had different shades of purple. So we were wondering if they were using different dyes, different colorants. What you see in color, like the square that you see highlighted, is the hyperspectral cube. So after the processing. So we have done spectral angle mapper. Remember what we mentioned before, that shows you the pixels that have a similar spectral signature. Exactly. So let me show you a bit more detail. And also you can see that Selene is giving you information about the weaving technique and the repairs.
Western wrap.
Exactly. It's so detailed. Textiles, I think, are really great objects to study with both techniques together, because you can, on the one hand, understand the weaving technique, and on the other hand, the dyeing process as well, and the complexity and sophistication of these kind of objects. So let's unveil the mystery. So what did we find? You can see that, well, I don't know if in this picture you can see it very well, but the hue of the vertical band all around the textile and the hue of the pattern with the birds is not exactly the same. This is a bit more purplish and this was a bit more brown. So we capture the mean spectrum in the different areas. So the background, the bird, and the band, edge. Exactly, the edge. And this is the result of the reflectance spectrum. Can you see in the purple spectrum, you have two main minima, so the absorption bands. This is already telling us that we probably have a mixture of dyes there. So this one on the right looks like indigo, which has this kind of elbow shape. It's an asymmetric absorption band around 660. And then you have another one here. We also did some fluorimetry because this under UV light was quite fluorescent. It looked a bit pink, orange. So it immediately made me think of mother, which has this property of fluorescing under UV. And when we look at the emission bands, we think that exactly that's what we have. It's a mixture of indigo and mother. So it's what they call a false Tyrian purple. Because if you have heard about Tyrian or imperial purple, that was extremely expensive. It's obtained from the murex mollusks that grow in the Eastern Mediterranean. And to produce a gram of dye, you need a humongous amount of mollusks. So it was very, very expensive. And it's called imperial purple because at some point it was reserved. It was only the emperor had the right to wear the purple robes. So this is the false version of that. It's a mixture of mother and indigo that looks purple, but it's not the real thing. It's cheaper. It's also more dented with iron, which also dulls the color, makes it a bit darker, a bit less bright. Exactly. So it has iron in it. So it's deliberately made to look a bit darker. Okay, we know what the edge is made of in terms of the colorants. What about the bird? We think that here we do have the Tyrian purple. It's still very preliminary, but the reflectance spectrum, a very little emission here could be related to the bromine indigo. So we think that they were keeping the expensive dye for the main pattern of the textile, and using the false one, the cheaper one, for the edge, for the borders that were less prominent. So it's telling us about the sophistication and the complexity of how these amazing textiles were made in the 6th to 7th century. We found the bromine as well, so that's kind of the giveaway. When we saw bromine in the XRF, we thought, oh, wait a minute, maybe we do have the actual Tyrian purple here in the birds. So still work in progress, but it's looking very, very promising. And definitely Selene was helpful to understand the other part of the production of the textile, which is the more mechanical, the weaving methodologies. Do you want to mention anything about this one or the previous one?
No, it's okay. It's okay. This one, the peacock, it's incredible. Another textile from Instituto Valencia from the 10th century. Caliphal textile, maybe I mentioned that before.
Cordoba.
Yeah, from Cordoba. And on the left is the color 3D image, and on the right side is the 3D plus spectral angle mapper image. Here, maybe you agree, Lucía, the most important thing, or because not for us only, for the institution, is to understand the threads, the gold threads on the peacock and around the peacock, in this part and outside of the peacock. So this is a detail, the peacock, and it's amazing. So if you want to explain this.
Yeah, so after the Selene scan, where I don't know if you noticed, but all of that is gold thread. All the background is gold, and also some of the details in the peacock are made of gold and the decoration around it. You can also see the weave very nicely. The resolution is incredible. It really allows you to understand the tension and the fineness and how the textile is made. Also the damage that it has suffered, like in some areas as you are seeing on the screen. And then my job was to look at the composition, again, the composition of the materials, the chemical analysis of it, and see if it matches what we see from the micro relief. So here we can see that indigo, remember that little elbow absorption band that I mentioned before? We have it here as well in the dark blue and in the green areas. The green areas are over here and here. So we have pure indigo in the peacock feathers, and indigo plus a yellow dye that we know is a Persian berry, which produces a yellow dye in the greens. The reds look insect-based, so reflectance spectroscopy can kind of distinguish between an insect-based dye, like cochineal or kermes, from a plant-based dye, red dye, like madder or Brazilwood, for instance. Here we can tell that it's insect because of the position of two tiny absorption bands around this area. But we were lucky enough to find an old report from 2005 of some sample analysis that was done at the Institute of Patrimonio Cultural de España here in Madrid. And they use a destructive technique. So HPLC, which stands for high performance liquid chromatography. So we know exactly what these dyes are. And it's helpful because it shows you the limitations of your non-invasive approach. It tells you how far you can go. So we were right, it's an insect-based dye, but HPLC can tell you which one. So it's kermes. You can see the kermesic acid in the mass spectrum. And not only that, but you can see mixtures of dyes. So it's actually a combination of kermes and madder. Tiny bit of madder was added to the kermes, which was very, very expensive as a dye back in the day. So looking at this textile, the amount of gold, the fineness of the textile, the silk, and the presence of kermes is telling us about a high-end, high-status, luxurious textile from the context of the royal, like the Caliphate court, which went to the Pyrenees, because this textile was connected to Roda de Isabena in the Spanish Pyrenees, the border with France. And the theory is that it's a diplomatic present, or perhaps that it's a textile that was recycled to maybe wrap a relic or some religious, very precious object and end up in this church in the Pyrenees of Spain, all the way from Cordoba, which is telling us about what I mentioned before, transculturality, connection between religions, between cultures, which is very, very interesting. Okay, so the last thing... Yeah.
That's a really nice interpretation of our hypothesis, because the peacock, it's in iconography, it's symbol to represent Jesus Christ.
Sure.
So it could be, it is pretty nice.
A good example of transculturality there.
Something that I would like to add,
yeah,
and maybe some of you are asking or about which is the difference between multispectral and hyperspectral.
Mm-hmm.
I think we didn't mention before.
Yeah.
Just to mention briefly, with multispectral, we have only around 10 bands of information, and hyperspectral, it's 1,000 of bands. So with actually multispectral belongs to some techniques that are called imaging, like normal photography, or translucent lighting, racking light, etc. But hyperspectral imaging belongs to spectroscopical techniques, where you are able to identify pigments. Before we, maybe you remember the part of the image with false color, and we have been talking a little bit about false color. Yeah, maybe. Right.
Was in the video, maybe.
Yeah, was in the video. But I think this is important, because with a false color, we cannot identify. We cannot be completely sure about the pigments. That is the reason why we have to use, and it's much better if you are able to analyze something with hyperspectral. So maybe it's around
the one on this one. That's so color.
It's this is a perfect example that you mix too many all the techniques to achieve all the results and to be sure about something. It's not enough using only one technique. That's the reason why most of the time, if you have one question, you have to go on it from different point of views.
Yeah.
Just that, because I think it's
a very important point.
Yeah.
Because all these techniques, one solve all your questions. They are complementary.
Exactly.
You get a much, bigger picture if you use them combined. So as an example of that, here we have some microscopy details, because the last thing we wanted to understand about this textile was the technology of the gold threads, because that's quite peculiar. It's very particular of the different cultures, the way they were making their gold threads. And I don't know if you can see in the microscopy images, but the gold threads look quite flat, like strips that have been gilded. And that's quite right, actually. So basically what we have here is the Islamic gold thread, where you have a gut or parchment that is gilded on one side or both sides, and then twisted around a core made of some silk threads. And that's exactly what we are seeing here. And also here in the kind of decoration of the peacock feathers, the eye, the background. So this is telling us that here we have an Islamic technique. So it's an Islamic textile, which kind of traveled to the Christian world and ended up in a Christian monastery. But the materials and the techniques are very characteristic of the royal workshops in the court of Cordoba. The colors, the way the gold threads are made. So I think it's really, really interesting to see how objects travel through, religious borders and cultural borders and kind of pick new meanings, as you were saying before about the peacock. That's the kind of thing we like.
Yeah.
Okay. The last example.
Please.
Do you want to introduce the object? Because this is the one that gave you kind of the epiphany of our collaboration.
Yeah. Going back as we start, if you remember, I start with an object, and the organic process that we have here, we can come back to the object. So that is lovely to me, because the hypothesis that we had about the relationship, about the micro relief on the surface and the pigments and the binders is here and is true. So this is the most important part and the final part. Thank you for being here with us. So Nasrid style tiling from the 14th century, as well from the Instituto Valenciano One collection. Okay, so here we have 4 images: the color 3D, the color 3D plus infrared reflectography, the color 3D plus principal composition analysis.
So basically the processing of the hyperspectral cube. So at the bottom, you have 2 different processing methods. On the left is principal components analysis. So basically it highlights in different colors areas that that explain the difference between the materials, between the different areas of the image. And on the right, spectral angle mapper, the one that we mentioned several times in this presentation, that is telling us about similar composition, similar spectral features. Should I continue from here?
Yeah.
Okay. So basically, in this image, a bit more zooming in, a bit more detail, we can use this as an example. So Santi, when they scanned this tile, noticed that, for instance, these 2 tiles, the ochre ones, showed a very different relief.
Black color.
Exactly. So this one looked a bit more, in good shape, smoother, no pitting, no cracks. But this one was completely damaged, cracked. Oh. The surface was more irregular. Same between this one and this one. But we observed like different behaviors across the tile. But yeah, we could not explain why. And that's why we thought, okay, let's try and scan it and see if the chemistry explains the behavior at the surface, like a different texture. And that's what we did. Even if the colors are quite similar, they are both ochre, when you analyze the spectral features, you can see that the colors, it's the red one and the blue one. They look very different when you map their spectral features. So they are differences in their composition. Let's see what they are. So basically here, we have analyzed the mean spectrum of each area that we were interested in. And we also did quite extensive analysis with XRF, because just to make it clear, this is a glazed tile, it's a glazed ceramic. So this is not a paint layer with pigments and binders, it's a completely different technologies, more similar to glass. So we are looking more at the elements that, the inorganic elements that explain the color or the function within the glass structure and in the different areas of the tile. So XRF told us that this is a lead-based glass, which was very common in Nasari glassmaking. So it corresponds with the context, the cultural context in the period. And then the different tiles were telling us like a little bit more about the manufacturing of this glazed tile. So in the white areas, we found a lot of tin, which we know in glassmaking was used for as an opacifier, so to make colors more opaque and whiter. So it makes sense that we find tin in the white or kind of cream color areas. Then the black areas, we found 2 different chromophores. In the calligraphy, we found iron, but in the tiles, this kind of lower decorative frieze, we found manganese. So similar color, which by the naked eye you would never tell the difference, but chemically completely different technology. And that shows as well in the PCA. The hue is different from the writing to the tile. The green color, the colorant would be, the chromophore would be copper ions. And in the blue, which is a bit out of the field of view of this image, but we analyze it as well, we had cobalt and nickel and tin. So let's go finer. Let's see if we can find small differences between the two ochres that we have learned that they are colored by iron. When we looked at the different X-ray spectra, we saw that the ochre tile that was in better shape had a much higher silicon peak and a lower iron peak. And in the darker one, the one that was more cracked and damaged, the ratio was kind of flipped. We had lower silicon and higher iron. And that corresponds with the typical deterioration of glass hydrolysis. So basically the glass structure is made of the silicon oxygen bonds, and that's breaking down. So the silicon is kind of traveling towards deeper layers. The structure is getting weaker structurally, and then it's becoming richer in iron relatively because we are losing silicon. I don't know if I'm making sense, but basically that kind of explains chemically what we are seeing when we look at the texture. So it makes absolute sense. It's telling us that the area that Selene saw as more textured and crackled is actually more deteriorated chemically. So that was the conclusion. And it was a very good news. And I think that's probably the end of our talk. Thank you for listening. Thank you for your patience.
Thank you very much for these marvelous insights and for sharing the work, and which is really a work in progress, because I know that you have been recording, or in some case, last week, and processing in the very last day. So thank you very much. I didn't want to interrupt you because I knew that this last part was the most exciting, maybe. We are a bit running out of time. So I would invite participants to quickly type their question if they have questions related to this last part, or otherwise we are always open to maybe address other inquiries via email. A question about the multi-viewer software that we saw. Well, what you saw in the video especially is in fact a Factum custom viewer. So it's not really openly available.
It is openly available to watch it and to...
Exactly. It's the tool we have.
Yeah. Sorry for interrupting you.
I just wanted to say something. Can I say just one quick thing? I just wanted to say that Santi has spent so much time registering the images, and it was very challenging. So I just wanted to thank you publicly for all your work, because it wasn't easy, and that was the key for the success of this collaboration. So
thank you.
Well done.
You. They, of course, they helped me too much. It's at the end of the day, it's a teamwork.
Exactly.
Very much appreciated. And well, going back to the viewer, yes, this is the tool that we found to share also with researchers, for example, the results, and with institutions too. I just wanted to add what maybe John before mentioned, or William, I don't remember. What Jorge Cano is working on now, and the different type of viewer to inspect the object like in a more three-dimensional way. I don't know if it's really correct to say that. Well, will be out soon, and probably will present it as well publicly.
Thank you.
Thank you so much.
I want to say thank you also to my team members, Juan Torrejón, Ana Calado, and Brianda Otero. They are amazing, and they have worked also to get these results.
Thank you. Thank you.
Great. So we are closing with one of my favorite pieces of the Instituto Valencia de Don Juan, like one of those that we scan that I love the most, because it tells a lot about its history just by inspecting its colors and cracks and now components. We are closing this five classes course, and well, the entire course will be up online, I hope very soon. And for the time being, thank you again to everybody, and see you next time. Bye bye.